So how to find the x-intercepts, the vertical asymptotes, and the holes. What we're going to do first, we're going to write the function in factored form. This is going back to Algebra 1. Everyone, go ahead and factor the numerator and then factor the denominator. Ready? Go. All right, Trisha, what did you get for the numerator?
X minus 3 and x plus 1.
Perfect. Prachi, what did you get for the denominator?
Oh, sorry. X plus 2 and x plus 1.
Perfect. All right, so step 1 is completed. We put it in factored form. Next step is cancel out common factors in the numerator and the denominator. Fernando, do you recognize any common factors that we can cancel out?
X plus 1.
Perfect. X plus 1 and x plus 1. They have that in common, so we're going to cancel those out. That's step 2. All right, so my simplified function is x minus 3 in the numerator and x plus 2 in the denominator. Now, we're going to go ahead and find the x-intercept, the vertical asymptotes, and the holes using these instructions. First, let's find the x-intercept. X-intercept, it says set the numerator of the simplified function to 0 and solve. This is the numerator. I'm going to set that equal to 0 and solve. When I solve, Quinn, what do I get?
X equals 3.
Perfect. X equals 3. So write it as an x-intercept. And that's your x-intercept. Next, we're going to find the vertical asymptotes. The instructions say, set the denominator of the simplified function to 0 and solve. This is the denominator. If I set that equal to 0 and solve, Henry, what do I get? What do I get? Perfect, -2. That is my vertical asymptote. All right, now we're going to find the whole. It says if there was a common factor. Was there a common factor? What was the common factor? X plus 1 was the common factor. It says set it equal to 0 and solve for x. When I set that equal to 0 and solve for x, Dia, what do I get? I get -1. That is the x value of the whole. So for the whole, I know I'm going to get -1. Let's continue reading the instructions. Substitute this x value that we just found, into the simplified function to find y. So guys, this is the simplified function right here. I'm going to take away these x's and substitute in my -1. Let's evaluate. -1 minus 3 is -4. -1 plus 2 is 1. This is just -4. So that is the y value of my whole. I'm going to factor the numerator. What can this and this both be divided by? Just a 6? 6x. So 6x will be on the outside. Tell me what's left over. Very good. The denominator. What can both of these be divided by? X. So that will cancel. Okay, so those are my factors. I can do an eye chart with this one. Can y'all tell me 2 numbers that'll multiply to -1, add to 0? Perfect. So this can be written as 6x, and this is x plus 1 and x minus 1 in the numerator, and this is in the denominator. Do you guys see any common factors? Good. There's an x in the numerator and an x in the denominator. Cancel those out. So your simplified function is 6x plus 1, x minus 1, over x minus 2. This is what we're going to use to make our decisions. Okay, x-intercepts. It says set the numerator equal to 0 and solve. I'm going to do each one. Let's do this 6. 6 equals 0. Does that make sense? No. That's not an x-intercept. Let's set this one equal to 0. X plus 1 equal to 0. Can I solve it? What do I get? -1. So this is one of your x-intercepts. And set this one equal to 0. What will you get? 1. So you have two x-intercepts at -1 and 1. Vertical asymptote. You're going to set the denominator equal to 0. So set the denominator equal to 0, and then we're going to solve it. Add 2, you get x is 2. That is your vertical asymptote. Holes. Do we have a hole? Why do we have a hole? Exactly, because we canceled out the x's. So whatever we canceled out, we're going to set it equal to 0 and solve. So we canceled out x's. So set that x equal to 0. And that's it. That's your x value of the hole. So I know that my x value of the hole is 0. Let's find the y value. So I'm going to plug that into my my simplified problem. Oops. Okay, so I'm going to erase these x's and put this in, my 0. So plug in those zeros. So this becomes 1, this becomes -1. So I get 6 times 1 times -1 over -2. 6 times 1 is 6, times a -1 is -6. Over -2, what do I get? Perfect, that's your hole. Horizontal asymptotes. What this is saying is if the degree of P is greater than the degree of Q. So what they mean is the degree of this polynomial, let's say it's x cubed, and the degree on the denominator is smaller. P is greater than Q, the degrees. We call that bigger on top or big on top. If the degree on the top is bigger than the degree on the bottom, that means you have no horizontal asymptote. It's just none. You don't have one. And an example of this, let's go back to the examples we had in our notes. Let's see if there is one like this. Oh, this one right here. It's bigger on the top. This is the degree 3, and this was a degree 2. So this does not have a horizontal asymptote. Make sense? That's an example of one. So an example, I can put 6x cubed, whatever that was, minus 6x over x squared minus 2x. It's bigger on top. Next one, if it's bigger on the bottom, the degree of polynomial P is less than the degree of Q. We call this big on bottom. If it's big on bottom, your answer is y equals 0. And an example of this can be, you have x minus 6 on the top, and then you have x squared minus 3x on the bottom, plus 3x on the bottom. The degree is bigger on the bottom. If this is the case, your horizontal asymptote is y equals 0. So an easy way that some people like to memorize this is big on top, B-O-T, bot, none. If you get a bot, you don't have anything. If you have Bob, big on bottom, it's 0. Some people say Bobo. Big on bottom, your answer is 0. Okay, next. If your degrees are the same, the exponents are the same. Write that down. If the exponents are the same, you are going to divide the coefficients. So an example, let's say I have x squared plus 2x minus 1 or plus 1 and over x squared minus 3x minus 2. I just made something up. Okay, you guys see how the degrees are the same? That means you would divide the coefficients. So what are the coefficients here and here? Just ones. So your answer would be y equals 1. Let's say this was a 4 and this was a 2. What would it be then? Yep, it would be y equals 2. If this was a 14 and this was a 2, what would your answer be? 7. You would divide the leading coefficients, okay? An abbreviation that people use to remember this is exponents are the same, eats, divide coefficients, eats DCE. So you have bot, none, bobo, eats DC. Those are quick ways to memorize it. So let's look at some examples. I'll do the first 3 with you. Is it big on bottom, top, or the same? Yep, they both have degree 2. So what do? Yep, 1 and 1 is just 1. Okay, big on bottom, top, or the same? If it's big on top, what is it? The answer is none. You do not have a horizontal asymptote. This one, big on bottom, top, or none? Or the same? Big on bottom, what is it? Yep. You guys can do the rest. Well, is it same or same? So what's the answer? 2, because 8 divided by 4 is 2. All right, guys, we're going to put everything together. Go ahead and factor that numerator. I want you to find the x-intercepts, the vertical asymptote, horizontal asymptote, and holes. We will talk about the y-intercepts in a moment, but you should try to remember from Algebra 1. How do you find y-intercepts? Exactly. You plug in zeros. Yep, plug in zeros for the x. So you do know how to find the y-intercepts. Find everything. Find everything. Ready, go. All right, look up here and see if you got it right. First, you had to factor this. This can be 2 times x minus 3. These are your factors. Does anything cancel? No, that means there's no holes. In order to find the x-intercept, you set the numerator equal to 0. So I'm going to do 2 times x minus 3 equal to 0. I can divide both sides by 2, and I get x minus 3 equals 0, and then I can add 3 to both sides. So I get x is 3. That means my x-intercept is 3, 0. Y-intercepts. I'm going to plug in zeros everywhere. So this is my original problem, or this is my simplified one. I can plug in zeros here. 0 minus 1, that's negative 1 in the denominator. 0 minus 3, that's negative 3, times 2 is a negative 6. This simplifies to just 6. So my y-intercept is at 0, 6. Vertical asymptote. You set the denominator equal to 0. Well, let me replace these back with some x's. Set this equal to 0, solve it, you'll get x equals 1. Horizontal asymptote. Is it bigger on top, bottom, or the same? It's the same. This is x to the power of 1, x to the power of 1. So guys, what is it? Yep, y equals 2, because you get 2 over 1, which is 2. Okay, so I'm going to plot all of these on my graph over here. The x-intercept is at 3, 0. That's right here. I have my y-intercept at 0, 6. That's right here. Yep. And my vertical asymptote, I'll do it with the highlighter so you can see it. Vertical asymptote is right here at x equals 1. Horizontal asymptote is at y equals 2. Okay, so this is what my graph is going to look like. Oh, and I don't have a hole. So then my graph will look like this. Go through those points that you just plotted. All right, let's talk about the domain and the range. Domain, I'm going to start on the left. Let me get my highlighter. For the domain, you start on the left. What am I going towards on the left? Negative infinity. So that's negative infinity. Now continue following the line. What does it go towards? What's right here? 1, the asymptote. So that's going to be 1. And let's continue right here. Where is it? It's close to 1. And then it goes to the right, towards infinity. This is how you would write it in interval form. What's a quick way to write this? Right, x cannot be 1. Now let's do the range. Here's the bottom down here. That's negative infinity. And it goes up to the asymptote. Where is your asymptote? 2. Now continue to the other one. Here's at 2. And then it goes up to infinity. What's a quick way to write this? Y cannot equal 2. All right, as you guys are working, I'm going to put the answer up here on the board. You can factor this numerator as x plus 1, x minus 1. Does anything cancel? Exactly, thank you. So that means I will have a hole because something canceled out. I'm left with x plus 1. What can I put on the bottom to make it a fraction? A 1, okay. So to find x-intercepts, you set the top equal to 0, right? What do I get? Negative 1. Okay, y-intercepts, what do I plug in? A 0. What's 0 plus 1? 1 divided by 1? Okay, so my y-intercept is just 0, 1. Vertical asymptote, what do I do? Exactly, I set the denominator equal to 0. Does 1 equal 0? Okay, so there's none of those. No vertical asymptotes. We set the bottom equal to 0, and it wasn't true. It made no sense. Horizontal asymptote, let's look at the original problem. Is it big on top, bottom, or the same? Yep, it's big on top. So what do I say? None. Remember, if it's big on top, the answer is none. Now, we do have a hole because we canceled out. So the thing I canceled out, if I set it equal to 0 and solve it, what will I get? 1. That is the x value of the hole. Let's plug it into my simplified problem. What do I get? 2. So that is where my hole is. Let's go ahead and graph everything. I'm left with, let me put my original problem back up here. This is what I had. When I canceled it out, I'm just left with the line. That's back to Algebra 1. This is my y-intercept at 0, 1, which we found it here, and it's just that. And my x-intercept is right here at negative 1. This is just, and then my hole is here. This is just a straight line, guys. This is like mx plus b. Your slope is 1. So you go up 1 over 1. So your domain, you can be everything except for where that hole is. The x value of the hole is 1. Your y value, you cannot be where the hole is. The y value of the hole is 2. So whenever you have a squared with the c term, you can do an eye chart. The c term is negative 1. You don't have the middle term 0. So two numbers that multiply to negative 1 and add to 0 will be negative 1. So that's why those are my factors.
Oh.
All right, guys, when you factored it, let's see, Larabe, what are your factors? Very good. Larabe, what cancels out? Just the 5s? X plus 5, the whole factor. Those cancel out. What does that mean if I cancel out, Larabe? No holes, good. Okay, so my simplified answer, I'm going to have 1 over x plus 4. Okay, so let's start finding our items. How do I find the x-intercepts? Yep, set the top to 1. So I get 1 equals 0. Does that make sense? Okay, so there are no x-intercepts. Y-intercepts, what do I do?
Under zero.
Plug in zeros. So I only have one x there. If I plug in a 0, what do I get?
Plus
1/4. That's your y-intercept. I'll go ahead and plot that. It'll be really small down here. Okay, vertical asymptote. What do I do? Thank you, Jocelyn, whoever said that. Thank you. Set the bottom equal to 0. If you solve, what do you get? -4. X is -4. Horizontal asymptote. Look at the original problem. Was it big on top, bottom, or the same? Big on bottom. You could also look here. That's fine. It's big on bottom. So what does that mean? Y equals 0. If it's big on bottom, your answer is 0. Whole. Whatever I canceled out the x plus 5s. You set it equal to 0 and you solve. When I solve, what will I get? Good. What do I do with this -5? Plug it in to find the y value. So I know the x value is -5. I will plug this in right here. And what will I get? Yep. This will become 1 over -1, which is just -1. So that is where my hole is. I'm going to go ahead and plot my hole at -5, -1. I have a hole right there. Let me go ahead and also graph my vertical asymptote. That's at -4. And my horizontal asymptote is at y equals 0. Okay. I'll go ahead and plot my graph. It's going to look something like, make sure you go through those points you just made. That's what your graph should look like. Okay, your domain. X cannot be what? Yep, -4 and -5. Because you have an asymptote at -4 and you have a hole at -5. So you can't be either of those numbers. What can y not be? Exactly, 0 and -1. Because you have a hole at the y value -1 and a horizontal asymptote at 0. Okay, how to factor the top? 2 times -1 is -2. And the middle value is -1. What are my two numbers? Perfect, -2 and 1. So I'm going to expand this. 2x squared, I got -2, so -2x, and a 1, plus 1x. And then continue writing it. Split it down the middle. We're going to factor out the GCF. So 2x will be on the outside. I'm left with x minus 1. Over here, I can divide by 1. So 1 is on the outside, and I'm left with x minus 1. Whatever is the same will go into one parentheses. Whatever is on the outside goes into the other parentheses. So this is the numerator factored. Okay, does anyone know the factors for the denominator? Exactly, x minus 4 and x plus 3. Does anything cancel? What does that mean then? No holes, nothing canceled out. There's no holes. You guys should have 2 x-intercepts. Thumbs up if you got 2 x-intercepts. Perfect. You set this one equal to 0, solve it, and this one equal to 0 and solve it. All right. Next, y-intercepts. What do? Plug in zeros. So I'm going to erase all of these. Actually, I'll just put zeros right here. This will become a -1 Plug in a 0 here, this becomes 1. Plug in a 0 here, this is -4. Plug in a 0 here, this is 3. -1 times 1, -1 over -4 times 3, -12. So I get 1/12. So 0, 1/12 is the y-intercept. That's very small. Vertical asymptotes. How many are there? 2. How do you find the vertical asymptote? Set what to 0?
Denominator.
Yes, the denominators. You have to set the denominators equal to 0. Okay, so guys, set this equal to 0, you get 4. Set this one equal to 0, you get -3. Those are your 2 vertical asymptotes. I'm going to go ahead and graph those. I have one at 4 and one at -3. All right. And my y-intercept. Oh, why did I draw a horizontal one? I'm sorry. There are 2 vertical ones. There is a horizontal one. Sorry, 4 and -3. Those are my vertical ones. So -3 is right here. There we go. All right, guys, horizontal asymptote. Is it big on top, bottom, or the same? Yep, they both have exponents of 2. So what do? Yep. The coefficients, 2 divided by 1 is 2. So my horizontal asymptote is here. Let me show you how to graph it because it's going to look weird. Your x-intercepts, go ahead and plot them. I have one at 1, 0, and the other one is at -1/2. Your y-intercept is really small. It's right here. This is what your graph will look like. That's what your graph will look like. Let me draw that better. You shouldn't cross any asymptotes. All right, guys. So your domain, x cannot be -3 or 4 because you have asymptotes, and your range cannot be 2 because of your asymptote. We did not have any holes.